In this lesson, we'll use a pump object to control an unruly river simulation. So I'm starting with these elements here in my scene. I have a sphere that I've called emitter. And then I have this piece of geometry that's a grid that I used a sculpt node on again. Just sort of smoothed it out so I didn't have as many bumpy edges. And then did an extrude volume. And all the extrude volume did was just give me a sort of some guts here so that I have something to use as collision geometry. So I'm going to go ahead and take my emitter and create a source out of it. So I'm going to come over to the Particle Fluids tab, and I'm going to create by clicking Emit Particles. Of course, I'm prompted here to now select a fluid or fluid box to add source to, and since I want to create a new one, I'm just going to hit Enter. And now I have my fluid source. Of course, I need my fluid source to actually collide with my geometry here, so I'm going to turn my geometry into a static object. I'll come over to my riverbed, come over to the Rigid Bodies tab, and choose Static Object. Now in the collisions course, we discussed fluids colliding with volumes and how sometimes it's actually better to use edge detection. Let's go ahead and play this through once and see if we have any problems we need to correct. Certainly, right off the bat, we can see here that on the right-hand side, our fluids are actually penetrating this particular part of the geometry. So what we need to do is examine our collision geometry real quick. We'll dive inside the Autodop network, and I've got a little bit of a mess here. I'm going to tap L, that'll lay out my nodes so I can see them. Now all of the steps that I'm doing here we've covered in the collisions course, so if you haven't had an opportunity to see that course yet, go ahead and pause this one and watch the Introduction to Collisions in Houdini. All of the things I'm doing here as far as changing this collision geometry around and making it better set up for fluids are discussed inside that Introduction to Collisions in Houdini course. But so real quick, the steps are, select the riverbed, come over to collisions. I don't want volume-based collisions, so I'm going to uncheck that. And that means I'm going to start using my surface as the colliding surface, so we're going to turn on Show Thickness. So now we're actually seeing what the fluid will be colliding with. It'll actually be this green geometry now. And that's how we want to do that. So I'm going to turn off the thickness. I'm going to go back up to object level, and let's just play back now and see what we get since we've fixed the collisions. Excellent. We can see here on the left-hand side that these particles are no longer slipping through the edge of this edge of the geometry. However, here on this side of the riverbank, we're getting some crazy parts of the river that want to go outside of the basin. All I want to do is flood the basin. I don't necessarily want any of this geometry out here getting wet. I mean, these could be houses or a city that we don't want to fill up quite yet. We just want to flood the riverbank, or the riverbed here. So how do we control that? Well, one way to do it is to use a pump. Now, a pump is simply a way of creating a velocity volume that we can place anywhere in the scene that we want and give a little gentle shove to the velocity of any one of the particles that are in our fluid. Now, pumps can be made out of anything. I'm going to start with just a sphere. So I'm going to look at my top view, which I did by hitting spacebar and 2. You can also accomplish that by using this little drop down and using Set View, Top Viewport. So either way. So I'm just going to create a sphere here. I'm going to control click. That'll give me a sphere which is located at the center of my scene. And I'm going to play forwards just a little bit in my animation so I can see the point on the river where the fluid starts to escape. Okay, it looks like right in here I could use just a little bit of gentle velocity to sort of push that back down into play. So probably geometry in the direction something facing the opposite bank. So let's move this sphere into place here. I'm going to go back into my perspective view, and I'm going to shape my sphere just a little bit, sort of like a football. So I can tap Y on the keyboard. That will allow me to toggle through Transform, Rotate, and Scale. I'm just going to transform the shape of this sphere just a little bit here. Sort of make it a little football shape, and we'll drag it into position, which I'm guessing probably needs to be somewhere in here. And this way, when the fluid particles come in contact with it, instead of escaping on their own trajectory, they'll hit this velocity field and be pushed gently back into play. Make it just a little bit wider. There we go. Make sure that it's going to be in contact with the fluid. Excellent. And finally, I'm just going to spin it around a little bit so it sort of coincides with the position of the riverbank. Now, make sure I have my selection tool over here in my toolbar, and that I have nothing selected. Normally, before you do these kinds of moves, you want to rewind your timeline back to 0. However, I know that this process requires us to actually select the fluid, so I'm just going to play forward a few frames so that I have something to grab whenever the tool asks me for it. So again, nothing selected. I want to come over to the Populate Container shelf. Okay. Now, usually these are all tools that are used with volume fluids, but we know that FLIP is a hybrid solver. It uses both volumes and particles. So this is going to give us another opportunity to use these volume shaping tools as a part of our FLIP simulation. So nothing selected. We'll select the Pump from Object tool, and I'm prompted to select my pump objects. I'll select the sphere, and then press Enter. Now I need to select the fluid box to add the pump to. Well, I can do that by selecting any of these particles here. You'll see that I'm immediately taken into my AutoDOP network, and that I've selected my flip object, which is exactly what we need to have selected. So now I can go ahead and just tap Enter as the prompt suggests. And here I have this new sort of foggy looking cloud. And what this is actually a velocity volume. It's just a big blob of push. It's just a blob of velocity sitting right there on the riverbank. Well, let's see what the effect of it is. So let's rewind and click play. Here come the particles. And they basically pass right through it as if it doesn't exist. And that's because even though the velocity volume exists, it doesn't have any velocity inside of it. Now we can set that here inside of the sphere object. So this is the sphere that we made, and of course by default it's called Sphere Object 1. I'm going to go ahead and rephrase that. We're just going to call it Pump. So we'll jump inside of this Pump node, and here we see a very familiar structure. This is very much like the structure we saw whenever we originally created our source to emit particles from, a constant source. We saw our geometry turned into a volume. There was an opportunity to merge those together, and then an out node where the velocity was pumped over into DOPS. On the volume itself, in fact, you'll notice this is the same exact node as a fluid source, as if we were going to spit fluids out of it, but we're not. We're only using the velocity volume here, which is now called pump vel. Okay, so this is pump velocity. Problem is there is no velocity. We need to add the velocity here, and then give it a general direction in which it needs to face. Now, to set that, I'm going to look in the top viewport. So, in the top viewport now, I can see my volume here as it exists. All right. Let's rewind timeline, play forward just a little bit. There we go. Now we snap that volume into place. So here it is in the top viewport. I've added my velocity. Right now I have a velocity of 1 in y. Well, that's probably just going to shoot those particles straight up into the air. I don't really want that. What I want to do is kind of kick them back into play. And if we look at this little icon that's located underneath this tooltip here, you can see that we have our x, y, and z parameters, with z being this direction and x being this direction. So really what I want to do is give them a push in the z direction to kind of push them back into play into that basin. So let's come over here in the add velocity area and just add a 0.25 in the z direction. And you can immediately see that we got our guides to pop up and that they are facing in the correct direction, which is basically a push this way. Now let's rewind our timeline and see what we've got. Here come our particles. They hit our velocity volume, and yes, they are gently pushed back into play. They do not escape over the edge of the river. They actually just continue along the path and look quite natural, actually. We can stop, rewind this. Let's get a clear look at how that looks. We'll just turn the pump's visibility off. Now the pump still exists. We'll go back into a perspective view and we'll get a look at it as if maybe we were somebody standing in the canyon. So what we don't want, remember, is for particles to come flying off over the edge here. We want them all to come down the middle of our ravine. So let's rewind and click play and see what we've got. Well, here they all come, and they come right down the ravine. You can see that they get close. They actually still have the initial velocity that they're given when they're emitted. They're just pushed gently back into play. So it's not as if we just put a big roadblock up there, something that they hit and we can see a definitive, shape being dug out. It's just sort of a blob of influence that influences the particles back into the ravine. So there you go. One way to control an unruly simulation is to use pumps and sinks. Well, now that we know how to keep a river out of control, it's time for something completely different. Let's start looking at the viscosity attribute. We'll do that in the next lesson.